Thanks so much for joining. This is part 3 in the PICO-8 for Beginners game dev series. This is going to be talking a bit about how to get the pumpkin and player character we built so far to collide with objects and be able to jump off of them and things like that. So this is going to be a little physicsy. So this is where we got so far in the past 2 streams. We have a little pumpkin that moves around the screen when I press the arrow keys. We can collect little coins by moving over them, and we keep track of how many coins we've collected as a score in the upper left hand corner. So I want to have like blocks and things that the pumpkin can run into and can't run through. I want walls and things like that. So let's make some blocks, and we're gonna make blocks in the exact same way we made coins. Let's have a blocks be a list, and let's make a block. And where do we want to make the block? I don't know. Let's make it at 0.5050. And let's make it further down, 50, 80. And we'll just have 1 block for right now. Or no, let's just have 2. 20, 80. So we'll have 2 blocks side by side. We don't have a make block function yet. So let's do that. Function make block xy. What should the make block function do? It should create a new object, return a new object. Its x position will be whatever x we passed in. Its y position will be whatever y we passed in. We're going to also give it a draw and an update function, much like all the other objects we've created so far. And those take an argument of self, which is the block we're referring to. So we need to draw a block. Define block. Like this, kind of imply an indent. Sure, that looks neat. It's sprite 6 that we can see here. I'm going to just draw that sprite, which is sprite 6, and I'm going to draw it at the block's x and y coordinate. Easy enough. If we were to run the game right now, we still wouldn't see anything. That's because in our PICO-8 games _draw function, we're drawing the pumpkin, we're drawing the coins, but we're not drawing any of the blocks. We're going to just draw them in much the same way. For every block in that list of blocks, draw it. And now we can see our blocks. And we can move right through them. So we need to fix that. And let's actually... Our blocks don't do anything when they update right now, but let's call that update method on each block so that if we wanted to add a update method, it would work. Now I've made my blocks go up into the sky, but I don't want them to do anything. I just want them to sit still right now. So we have our check for collision method that we're calling on each coin. If we use this and called it on a block, it would mostly work. Except blocks don't have a concept of is collected, and they don't have a radius at this point in time. They just have a width and height. Let's call this check for coin collision. So let's give our blocks a width and a height, much as we did for the coins in the player, and let's draw that rect self.x, self.y. Self.width, self.y plus self.height, 8. So now we have a bounding rectangle around our block. And let's get our bounding rectangle around our pumpkin too. So our pumpkin has a width and a height. Let's draw the bounding rectangle. Rect, self.x, self.y, self.x plus self.width, self.y plus self.height. 7 width. And again, we keep switching back between whether or not the XY coordinate of the pumpkin means its upper left corner or its center point. And if we're using a rectangle based collision detection, we should have the XY coordinate represent its upper left point rather than its center point. It'll just make the math a little bit easier. Which means I think from this point onward, we're going to stick with axis aligned bounding box collision detection. I showed you how you can do circle collision detection and circle hit detection. But for our game, from now on, I think we're going to do rectangular-based hit detection. Which means I'm going to comment this coin collision out for now, which uses circle-based collision detection. And I'm going to get rid of our circles overlapping code since we won't need that anymore. We're committing to using rectangles. So I'm going to get rid of that. Farewell. We won't need to be checking whether a point is within a rectangle anymore, since we'll be using rectangles for all of our collision detection and hit detection. So we're going to get rid of that. Let's make a helper function that, so this rex overlapping function takes in a whole lot of arguments. And a lot of times what I want to do is I want to compare two objects that have an x, y, a width, and a height each. And I want to tell whether those are overlapping. And it sucks that I have to pass in pumpkin.x, pumpkin.y, pumpkin.x plus pumpkin.width, blah, 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 over and over and over again. So let's make a helper function that's objects overlap, or bounding boxes overlapping. And that's just going to take two objects, and it's going to see if their bounding boxes are overlapping. And it's going to be very simple. It's just going to call rex overlapping and pass in all the arguments. So to x, obj1.y, the x plus width, obj1.y plus obj1.height. It's already tedious writing this, just doing it this one time, and I never want to do it again. That's why we're writing this helper function. And the same thing with obj2. X, y, x plus width, y plus height, x, y, x plus width, y plus height. So all this function does is you give it two objects and it'll pass all the right things into rex overlapping. If we go back up here, we can now simplify our coin hit detection. Let's make it so our pumpkin no longer needs a radius. We're going to use rectangle based hit detection. Our coin doesn't need a radius anymore. Let's draw our coin's bounding box though. And they're a little offset again because of that coordinates issue. There we go. And let's get rid of that for now, and let's fill out our pumpkins. So now our pumpkins check for coin collision method should be super simple. All we need to do is if not coin dot is collected and bounding boxes overlapping self comma coin, then coin dot is collected equals true, score plus equals 1. There we go. So all this code we had before of like getting all the parameters out of those objects, now this bounding boxes overlapping code will handle that for us. Great. And now we can collect coins again. Lovely, but we still can't collide with the blocks. Let's do check for block collision. Function self block. So we're going to check for a collision between the pumpkin and the block. And right here, we're in our underscore update, we're updating every coin, then checking to see if a pumpkin is colliding with any coin. Same thing, we're going to update every block and then check to see if the pumpkin is colliding with a block. So we're calling that function now. The function doesn't do anything yet, but we can do that. So if we want to see if the pumpkin is colliding with a block, all we do is if bounding box is overlapping, self block, then we know that the pumpkin is overlapping with the block. Now here's the tricky thing, is what do we do in that circumstance? Our function check for bounding boxes overlapping properly checks to see if these rectangles are overlapping. So we can figure out if they are overlapping. But what I want to do is if they are overlapping, I want to move the pumpkin out of the block. Basically how games work in terms of collisions and handling colliding into walls and stuff like that is every frame So the game's updating 30 frames per second. Every frame you move your objects a little bit, and then you render the screen, you move your objects, you render the screen, and you keep doing that in discrete chunks, but because human eyes are silly, we interpret it as smooth movement. So eventually when we get really close to this block, what will happen is our pumpkin will move into it and they'll be intersecting. And before we draw this to the player, before we draw the fact that the pumpkin is inside of the block, we want to move the pumpkin outside of the block and then draw it to the player. But it's a little tricky to figure out the right way to move this orange pumpkin block outside of that gray block, because if after moving the pumpkin it's intersecting like this, what do we do with it? Do we move it here? Or do we move it here? Or do we move it here to like get it out of the block? It's a little bit ambiguous what we should be doing. So let's just for now, just to verify that things are working, if the pumpkin happens to intersect with the block, let's just move it away from it, just like maybe to some predefined point. So if the pumpkin and the block are overlapping, let's say the pumpkin's x is 50 and the pumpkin's y is 50. So now if I intersect with a block, it just teleports me away from it. Not the best way to handle collisions, not very robust, but at least you can keep a player from moving through walls now, but we can do better. So let's have this. Let's have it where, next step, if the pumpkin is colliding with the block at all, its bounding box is colliding with the block's bounding box, let's move it so it's right on top of the block, like this. So we're going to alter the y value of the pumpkin so that it's right above the block. So we're going to set, if the block and the pumpkin are overlapping, we're going to set the pumpkin's y to be the block's y. So now they would be on top of each other, but then we're going to move the pumpkin outside of the block by subtracting the pumpkin's height minus that height. And now when we run our code, we can see that if I try moving into a block, it teleports me to be above the block. And this actually feels pretty good if I'm moving into it from the top. It feels like the block is a solid object and I can't move past it. But if I moved into it from the bottom, it feels a little weird. Or it's the side, it feels a little weird. It kind of pops me up. Let's say I wanted also to, if the pumpkin is moving left into the block, I want to push the pumpkin outside of it to the right. But how can we do that? There's a couple different ways we could do this. One is, if the pumpkin is moving to the left and it ends up inside of a block, we just move, we don't have to figure out how it collided with it or anything like that. We know the pumpkin's moving to the left. To get it out of the block, we just try moving it to the right. And similarly, if the pumpkin is moving down and it ends up colliding with a block, however it does, we just get it out of the block by moving it opposite of the direction it's moving, which would be up. That's a fine solution. Super Mario Bros. Uses this solution where let's just kick the player object the opposite direction that they're moving to get them out of the collidable object. We're going to do it a little differently. Imagine you had a tiny little rectangle right here, and a tiny little rectangle right here, and one right here or something like that. So essentially we have, our little pumpkin has 4 detectors. Let's say I'm falling from the sky and I end up stuck in the block like this and I need to be moved out of the block. I'm just checking to see if this little thing or this little thing or this little thing are colliding with a block. And if they are, if this bottom red square is colliding with a block, I know that I need to move the pumpkin up to get out of the block. Or if this side little rectangle on the right side is colliding with a block, I know I need to move it left to get it out of the block. Downsides of this technique are if I'm standing like this, or if I'm colliding like this, it looks like the pumpkin is overlapping with the block right now. But if we're just using these little red squares to be our detectors for collision detection, none of them are colliding with the gray block right now, which means that this would not count as colliding or overlapping with the block. But it would mean that we would know which direction to move the player, and we just need to look at which of those little detectors is within the block. And we could end up with ambiguous cases where, let's say that the pumpkin was positioned like this, and now the top and the right detectors are both within the block, so we don't know if we should move it down or to the right. But this isn't so bad, because in a case where the pumpkin got into this position where both detectors are nestled within the block, it's usually an ambiguous case where to the player they also wouldn't know which way it should go. Like, it would look equally good if it moved it there or there, and it's just up to the programmer to choose which one of those to have priority. We're going to do it where we have 4 different collision areas, and we're going to check to see if any of them are colliding with a block. Depending on which one is colliding with a block, we know which way to move it outside of the block. So let's do that. We have this code right now that checks to see if any of this bounding box around the pumpkin is colliding with any of the bounding box of the block. But we're not going to use the pumpkin's big ol' hitbox for this. We're going to use 4 different smaller hitboxes. We won't be able to use our helper function. What we'll need to do though is let's take a look at this little red area here. Boop, boop, boop. If this is the pumpkin's whole 8x8 pixel hitbox, what would this area be? I want it to be half the height of the pumpkin on the lower side and inset by some number of pixels. And the reason we're insetting it is so that if the pumpkin moves horizontally and it gets nudged into a block like this, the hit detector on this side will detect a collision before this one does. Whereas as if this extended fully to either side, then this would count as a collision for this side and the pumpkin would be popped up, which we don't want. So let's do this in our draw code right now, actually. Let's try to draw the right rectangle. Let's also just get local variables x, y, w, h equals self.x, self.y, self.width, self.height. We're going to be playing with x, y, width, height a lot, so let's get those in smaller variable names. Local, I don't know if I explained this, but local creates a variable local to this function. So I've created x, y, w, h. I couldn't access x, y, w, h within this function because these variables are local to this draw function. So if we want to figure out how to draw this hitbox, this is, if this is the pumpkin's y value, this would be the pumpkin's y value plus half of its height. And then this would be the pumpkin's y value plus all of its height. So we're going to draw a rect, and we're going to have the x, the y, x2, y2, and a color. Let's just do 8. We know that y, the y value is going to be the y plus half the height, and the other y value is going to be y plus the full height. And then this is the x value of the pumpkin. This is the x value plus the width of the pumpkin, which means that this is the x value of the pumpkin plus some small amount, let's say 1 or 2 pixels, x plus 2. And this would be the x value of the pumpkin plus the width of the pumpkin minus 1 or 2 pixels. Let's do that. So x plus width minus 2. And let's see what that looks like. Yeah. Let's even just hide our pumpkin sprite for now. Cool. And let's fill it in. Fill. So we can see it a little bit better. So you can see now I'm drawing a little area of the pumpkin that is the bottom part of the pumpkin. So we've got all that correct. So let's see. This is the bottom hitbox. And let's figure out what the top hitbox would be. So if I wanted to draw this area, this is just the pumpkin's Y value. This is the pumpkin's Y value plus half of its height. And then these X values are the same as the red area, so we can just reuse the X values. The bottom hitbox, the top hitbox, blue, red. So X values are the same. The Y value is just the Y value of the pumpkin. The other Y value is just Y plus half the height. And then I want this to be blue. Great. We got that one too. They look to be different sizes. That's just a rendering rounding thing. So I want to get this little green area here, which will be used to check for whether or not the pumpkin is colliding with things on the left-hand side. Is the X value is just the X value of the pumpkin. The other X value is X plus half the width of the pumpkin. The Y value is Y plus some small amount like 2. And the other Y is the Y value of the pumpkin plus the height minus 2. Let's do that. The left hitbox. What did I do? Green. Green. Rect fill. It's going to be the X value. And then the other X value is X plus half the width. Let's make it green. The Y value is just the Y value of the pumpkin plus some small amount. And then the other one is just the Y value plus the height minus some small amount. And 11 is green, I believe. Call the global rect fill. Rect fill. Yes. So we've drawn this green area there. Only have one left. Let's do yellow. And it's going to be this area. I noticed when I did... One thing about this is I noticed that this yellow area is just the green area plus moved over this way along the x-axis by half of the pumpkin's width. So I can actually just like copy this. The right hitbox, yellow. So I can just move it over, translate it over by half the width. And that should be, I want it to be yellow, which is the color 10. Yay! Brief review of the colors. Red, 0, 1, 2, 3, 4, 5, 6, 7, 8 is red. 9, 10 is yellow. 11 is green. 12 is blue. And you can see 8 red, 10 yellow, 11 green, 12 blue. And we're not doing any hit detection anymore. We're just drawing the hitboxes. So rather than just drawing them, we need to check. And let's do it like this. The top hitbox. We have... Okay, I'm going to do some magic. So we're drawing these. I'm just going to turn them into variables. Local. Hitbox equals. Top hitbox equals. Let's make an object for each of these. We don't need the color. And what each of these... So I'm going to make an object for each hitbox that the pumpkin is going to be checking. And each of those will have an X, a Y, a width, and a height. And that will allow us to just use our bounding boxes overlapping function, because that just takes 2 objects, and we're going to create two objects. So the X, this is going to be the X value. Let's do it like this. I recognize that this is a little magic. That's okay. Hopefully you can follow along mentally. And then this is going to be, right, this is going to be the width. This is going to be the height. And actually, the way I was drawing these is the rect fill function takes x1, y1, x2, y2. Our bounding boxes overlapping function takes 2 objects with an x, a y, a width, and a height. So these width and heights are incorrect. I need to just change these. The height of the top hitbox, let's take a look-see. Doo-ba-doo. This is an extension called Snappy. The top hitbox, the height of it is just half the height of the pumpkin. The width of it is the width of the pumpkin minus 2 on one side, 2 on the other side for 4 in total. The bottom hitbox has the exact same height and width as the top hitbox. Ooh, whoops. This shouldn't be W equals. This should be width. And this should be height. The left hitbox, the width of it is half the width of the pumpkin. And the height of it is the full height of the pumpkin, minus 2 on the top, minus 2 on the bottom for minus 4 in total. And the right hitbox is the same width and height. And we need these same variables to be declared down here, the x, y, w, h, to make this simple. So let's see. Calculate the 4 hitboxes. So we're basically just making an object for each of these 4 hitboxes here that we're drawing to the screen. And what we can do is, this is where the magic happens. We've done all the thinking, we've written the helper functions, we've got our objects set up, and now we can just say, if bounding boxes overlapping, if the bottom hitbox is colliding with the block, then so we're talking about the bottom hitbox, which is that red thing. If the red thing is colliding with a block, then we want to move the pumpkin up, which means we just want to change the y coordinate to be the block's y coordinate minus the pumpkin's height to get it to be above it. Let's just try that out. Boop. Boop. So we still have that snapping problem where the pumpkin snaps above it. Boop. But that's because we're not checking any of the other ones. So let's do that. If bounding box is overlapping, if the top hitbox is colliding with the block, then what do I want to do in that case? So that means if this blue rectangle is colliding with the block, if they're overlapping, I want to move the pumpkin down, which means I want to set the y value of the pumpkin to be equal to the y value of the block plus the block's height, which will be the bottom of the block. Great. So then self.y equals block.y plus block.height. Let's try that out. Yes. And we still have a little snapping problem. Yeah, but now we can't go up through the block and we can't go down through the block. Let's finish this out. Let's just check the left and the right hitboxes. If we think of the green hitbox, if that's overlapping with the block, we want to move the pumpkin to the right, which means we'll want to set the x value of the pumpkin to be equal to the block's x value plus the block's width, which will be here. So we're going to set if bounding box is overlapping, the left hitbox, the block. Then self.x, x being the horizontal axis, equals the block's x plus the block's width. Can't move left through the block anymore. And let's just do the last one. If the right hitbox is colliding with the block, we want to move the block to the left, which will mean setting the x value to be the block's x value minus the width of the pumpkin. X equals block x minus the pumpkin's width. If bounding box is overlapping, the right hitbox is overlapping with the block, then self.x equals block.x minus self.width. Whew. Let's try it out. Yes. So now, no matter what I do, I can't get this pumpkin to be inside of that block. Great. And I still collect coins. And that's true for this one too. Yes! This is collision detection. This is what it looks like. Now we can build walls, we can build a ceiling, we can build a floor, a ground, and the pumpkin will be able to not move through them. We can leave that be for now. Actually, let me just clean this up. Let me one line these. Boop, boop, boop. I'm just getting them to be a little more less readable, but the function's a little bit smaller now, so it's easier to see. Oh, good. So this is what collision detection really looks like. Let's get rid of all these and get our pumpkin back so we can see our pumpkin. And we can see now our pumpkin can't get in that block. Let's make block. Let's get rid of the blocks bounding box 2 so we can see what it actually looks like. Great. Look at that. Sick. So, a couple of things. Let's make a bunch of blocks. Blocks equals. Let's make a floor of blocks and a couple of platforms of blocks that we can jump to. And what I'm going to do is, let's do this programmatically. We have a loop here, for coin and all coins. That's like for all in a list loop. I want to iterate local I for I equals 1, 20. I want to create 20 blocks in a line. And an easy way to do that, I could copy and paste make block 20 times. Or I can make a loop that says, take a variable I, start it at 1, increment it by 1 all the way up until 20, and each time I do that, make a block. And I'm going to specifically add to that list of blocks a new block, and let's make a block at 10 times I, 70. So I'm making a block at an X position that is 10 times the value of I. I goes from 1 to 20, one at a time, and at Y position 70. And if I were to run this code, you can see there's this long line of blocks going from the left to the right. I think 8 times I will actually make our blocks be right next to each other because there's a little 2 pixel gap between my blocks right now. And let's make it further down, maybe at 90. So now I've made a line of blocks. I don't actually need 20. Let's do like 10 or 15. There we go. So now we've told our a computer just make 14 blocks for me. I don't want to have to type it that many times. Let's also add. Let's make some blocks by hand though. Let's make one at 50. Yep. Let's make another one at 80, 60. Yeah. So now we've made some blocks, and the pumpkin still can't overlap with any of them. It will get kicked out of them. My pumpkin is still just kind of, let's get rid of these coins for a second. Let's just have there be, let's make some coins programmatically too. So we start with no coins, and then we're gonna make 14 blocks. Let's also just create 3 coins, add coins, make coin, 20 times I, 30 plus 15 times I, 80. So these should be, I have created 3 coins that are right above the blocks, which my pumpkin can collect. A problem with this 2D platformer is my pumpkin can just fly around the screen, which isn't very good. This doesn't make for a very good platformer. So I want my pumpkin to be able to move left and right, but I don't want my pumpkin to be able to move up and down. I want it to have to jump. But if I start with my pumpkin, and it's floating in the air there, when I hold down, what's happening is the y value is increasing. So maybe what I can do is in my update function of my pumpkin, I could just say self.y plus equals 1, and that will get my pumpkin to move down. That doesn't look quite right to me though, because it's not really accelerating, it's just slowly drifting downwards. Maybe if we move it a little bit more up, we can see that. 24. That doesn't look like what falling looks like. Falling is characterized by acceleration. So what I want to do is another concept that is in like every platform is the concept of velocity. Velocity is the change in position over time. We're going to have a velocity for y and a velocity for x. Let's call them velocity x, velocity y. And what we're going to do is every frame, we're going to add the velocity to the position. Velocity y. And that doesn't do anything now because velocity is always 0. So what I want to do is, let's have, if I were to set velocity x to 1, then the pumpkin will just keep moving to the right, even when I'm not pressing anything. Let's have it be that we're not going to let the pumpkin move up and down, but let's have it be that this is btn1 checks to see if the right arrow is held down. I'm going to say that if the right arrow is held down, don't just increment the position, set the velocity, self.velocity x to 1, or to self.move speed. And if the left button is held down, set the velocity x to negative self.move speed. And then the velocity x will change the position of the pumpkin every frame, which is good. And this should still work. I should still be able to move left and right. Oh, we have a problem. The problem is if I press left and I don't press anything, it will still move to the left because I set the velocity of the pumpkin to -1 and it just keeps moving that direction. Maybe what we could do is, this is sort of like a Mario-ish platformer where the you don't stop immediately when you release the button. You sort of just like via friction slow down to a stop. Let's do that. The way we do that is very simple. Let's say I were to press the right button, then the velocity of the pumpkin would be set to 1. And what I want to have happen is, in order to slide to a stop, that is equivalent to slowly reducing the velocity. So I'm just going to, and an easy way to do that is we'll do self.velocity x equals self.velocity x times 0.9. So if I press the right button and then let it go, what will happen is on the first frame, it will be velocity 1, then 0.9, then 0.9 times 0.9, which is even smaller, and then it will keep getting smaller until it eventually reaches about 0. And if we run that, we can see it does do like a little slide to a stop when I release left or right, which is what we want. And if we wanted to slide to a stop faster, we just lower this number, which would, like, for example, if I wanted to stop immediately, I would set this to 0, where the velocity, the x velocity just gets set to whatever the velocity is times 0, which will always be 0, which means it stops instantly. If I wanted to stop really slowly and slide a lot, I would set this to a number just below 1, which will slowly reduce the amount, but very slowly. Like it will be 0.99, then 0.987 or something like that. And you can see that here where even if I just tap the left arrow, it will very slowly decrease to a stop. If this number is above 1, then as soon as I press a button, the the pumpkin will start to speed up in that direction, which isn't what we want. So we'll zoom off. That's not what we need. If this were to be a negative number, it would do really weird things. Would it? Yeah. It would keep flipping back and forth which direction it's moving every frame. So that's not what we want either. If it was like negative 1.2, it might do something fun. Yeah, looks like it's doing. What's the move? What's the move in Pokemon? Double team? Double team. Looks like double team. But we want it to be, let's just do 0.9 for now. That handles the X velocity case, and you can see even now why velocity is useful, because we can do stuff like this with it. We can do times equals here, 0.9. But we need to handle gravity. We want it to fall to the ground. So what we can do is self.velocity y plus equals 0.1. Whoops, that was weird. I see why that's happening. So you can see it is falling. It's also moving right through our blocks, which seems like a bad thing. You might see this and be like, oh no, we built bad code. Very simple reason that's happening. I'm not too worried about it. But our pumpkin is accelerating downwards, which is what we want for our platformer. And it's collecting a coin on the way. Good for it. Let's fix that though. So what's happening? If our pumpkin is falling towards the screen, or falling downwards, what will happen is it will overlap with the block and it will be moved up out of it. But if our pumpkin is moving too fast, like let's say every frame it moves from here to here, or let's say it's right here and in one frame it goes from here to here, it will move right through the block. Because if it goes from here to here in one frame, there's no point where any of its hitboxes are touching the block. And this is a movement of like 12 pixels in a single frame. So our pumpkin is moving through partly because of that. It's moving so fast that it's just moving through it. The other thing is, if it moves such that it's like, if it moves from say here, if it moves from say here to here in a frame, it might check to see if it's colliding with the block, but it might check to see if the right side is colliding with the block first. And if it, because in one frame it moved into a position where all three of these hitboxes, actually all four of the hitboxes, are technically colliding with the block. So it's just a matter of which hitbox do we check first. That determines whether or not which of those hitboxes takes priority. Let's do a quick solution first, which is this little divot here is 2 pixels. That's how we coded it. Bottom hitbox. We can see that, like with the bottom hitbox, this position we're saying is x plus 2. So we're given 2 pixels of wiggle room, which means as long as the block doesn't move more than 2 pixels in any axis in a frame, we won't get into a situation like this. So one thing we could do is we could say, okay, before we apply our velocity, let's keep our velocity between negative 1.5 and 1.5. I talked about mid in the last stream, but if you missed that, it's basically a function that you give it 3 numbers and it will return the middlemost number, which if self.velocity x is really, really big, the middlemost number will be 1.5. If it's really, really small, the middlemost number will be negative 1.5. So essentially it keeps velocity x between negative 1.5 and 1.5. And we'll do the same thing for velocity y. Great, great, great. So now if we run our code, boom. So now our pumpkin can't move too fast in a single frame, but it does, or it can't fall too fast, but it does hit the ground and stay there. Super duper. Let's also handle the priority of these. I want, if the bottom box is colliding, like if multiple boxes are colliding, which ones do we want to matter the most? I think we want to check if the bottom one is colliding. That's probably the worst one because it means someone might fall outside the level. So let's check the bottom one first, and then the left and the right, and then the top. Bottom box, and then the left and the right, and then the top. And we'll do it like this. Else if. Else if. So now there'll be a maximum of 1 collision per box. That shouldn't change anything. If you wanted your pumpkin to move faster than 2 pixels per frame, there's a couple ways to do that. One is we could increase this divot here. So we could have the hitbox be like, so if we increase the divot, then even if it moves a big distance in a single frame, like it will still be the case that if it's moving down a bunch, we don't get into the situation where the left and right hitboxes will be inside the block before the left one is. Or another case is, since the red hitbox is being checked first now, we won't get into the case where if it's moving very fast to the right, even if it moves from here to here in a single frame, the red hitbox, the bottom hitbox, is still outside of the block. So this side hitbox will be checked first. Let's put it to the test. How fast do we want our pumpkin to move? Let's try horizontally first. I think I want it to be able to move speed 2. Let's get rid of these limits on the X velocity. That's a little fast. I think I probably don't need it to move that fast. Let's do 1.5 for the move speed. Boo-ba-doo-ba-doo, boop-boo. That seems like a decent speed for a pumpkin to move. So PICO-8 is a 128 by 128 pixel screen, which means if a object moves 1.5 pixels, it will either move 1 pixel or 2 pixels in terms of where it's rendered on the screen. And that gives it a little bit of a jerky feel, which you might be able to see by looking at that, that pumpkin. It kind of like jerks a little bit. This is undesirable, but it's not the worst thing in the world. Just something to be aware of. Feels like a good speed for a pumpkin to move. 4 seems good. Well, let's do 3. So then we need the divot. Instead of being 2, we want it to be at least, if we want our pumpkin to be able to move 3 pixels vertically per frame, we need this little divot here to be at least 3 pixels. And right now the divot is 2 pixels, so let's change this. So where it's plus 2, I want it to be plus, let's do 3.1. And where it's minus 4, it's going to be minus 6.2, which is double that. And let's create some blocks along the ground. Blocks equals. Let's add a block. So these are at 90. If I want a block that's right above that, that's minus 8 pixels, which is 82. Yeah. Great. It is overlapping the coins. Let's move it further over. Cool. Let's say we had a bullet and it was moving very, very fast. It was moving from here to here in a single frame. And this means that it could be that it moves from here to here and then it detects that it's colliding with the wall and everything's just fine. But it could be that it moves from here to here and it goes right through the wall. Oh no. What do you do? If you get into this situation, which I don't think we'll have to do this in this platforming game since we're not going to have any super duper fast projectiles, one thing you can do is you could split up this movement where instead of jumping from here to here in a single frame, you move it here, you check for collisions, you move it here, you check for collisions, you move it, you move it, you move it, you move it. And that will guarantee that even though no matter how fast the object is moving, because you're checking in increments of however small you need to check, it can't move through objects. So if you needed to, that would be the strategy for checking to make sure that an object doesn't go through another object. I've done that in some of my games. The code isn't too bad. We're probably not going to do that for this one. Let's make our pumpkin jump, though. I want to make my pumpkin jump. So that's code related to updating the pumpkin's position, so it'll be under the update function. What button do we want to be the jump button? Let's do Z. Let's do this. Apply gravity. Gravity. Self to X equals, we can do 3. Make sure the velocity doesn't get too big. Apply the velocity. Move the player with the arrow keys. Apply friction. And what I want to do is jump when Z is pressed. That's very simple. If button 4, that's the Z key. If it is held down, then self.velocity Y. So Y position, if Y is getting bigger, you're going down. If Y is going smaller, you're going up. I want to go up, which means I want to decrease my velocity. Let's set my velocity to -3. Bow. Bow. And now my pumpkin can jump. It can jump up. This isn't the best code though, because if I hold down the Z key, it just flies away, like pumpkins are wont to do. But I only want to jump if I'm on the ground. And the way we do that is, how do we know if we're standing on a block? We know if we're standing on a block by if we moved our player and this little red area triggered and moved us back up. Whoops. We know that if that red hitbox there, our bottom hitbox, if it collides with a block, then we know that we're standing on it because we moved up and now we're on top of the block. So, and if we go through a frame and this little red area doesn't trigger, then we're not standing on a block. And in this case, where the pumpkin is resting on a bunch of blocks, you might think that what happened is the pumpkin fell and then it moved up and then it's just sitting there and it's not moving at all. But don't forget that gravity is being applied each frame. So every single frame that this pumpkin is sitting here doing nothing, what's happening is it's starting to fall through the block, and then the block is saying, we're colliding, and then we're moving it back up. So the pumpkin is actually doing something like this, where it's going down and then being bounced back up outside of the block. It's just that it's being moved in the block and then being moved out of it every single frame and before it's rendered in the block at all. So every single frame, this pumpkin is colliding with a block, which means we can use that to see if it is standing on a block this frame. So let's do this. Is standing on block equals false. So it starts out not standing on a block. If bottom block, if the bottom hitbox of the pumpkin collides with a block, then is standing on a block is set to true. And at the end of each frame, so how this works is, the way we've organized our code, we update the pumpkin, and then we check to see if the pumpkin is colliding with any blocks. What I think I'm going to do is at the end of the pumpkin's update function, we'll set is standing on a block to false, which, if it then collides with any blocks, will get set to true immediately after that in the same frame. And if at the end of the update function I set is standing on a block to false, and then it doesn't collide the bottom hitbox with any of the blocks, then is standing on a block will be set to false and will stay false, which will mean it's airborne. So at the end of the update function, we're going to set this to false, but it will probably be set to true in the exact same frame if it's standing on stuff. Say the pumpkin standing on a block if its bottom hitbox collides with 1. These are just comments. If standing on a block is false. So all we need to do is when we're holding down the Z key, we only jump if we're holding down Z and we're standing on a block. Now, if I hold down Z, I just jump. I just jump whenever I'm on the ground. And if I don't hold down Z, I stand on a block, and if I press Z, I jump. Yay. This friction feels bad. It is like ugly ice. So I'm gonna up the friction. So now you only slide a little bit. Can't quite get there. If I wanted my jump height to be bigger or smaller, I would just change this initial velocity. So if I wanted my pumpkin to not jump as high, I can set this velocity y to -2. And then we don't jump quite as high. If I set my velocity y to -4, we're going to run into this thing here where we're clamping velocity between -3 and 3. I'm just going to up that for right now. Boing, boing. And now we can jump real good. The other thing we can do is we could keep our starting velocity at -y, but if we want to jump higher and longer, we could just change how much gravity is applied. So let's change gravity to 0.1. Did that change? 0.01. Now the pumpkin falls really slowly, and when I jump far too high. That's wrong. Let's do 0.1. Boing. Let's set this to 3. Boing. Yes. Go, little pumpkin. Let's solve one last thing, which is if I land on a block and then I sit here for a little bit, what's happening is the block looks like it's standing still, but it's actually building up vertical velocity because gravity is still being applied and it's cumulative. So when I move off the block, it just does like this sharp fall. Even though gravity is actually very gradual, it just falls sharply. And that's because the pumpkin already had a lot of vertical velocity. It just kept bouncing into the block. So when you move off of it, it just shoots right down. I don't like that. I want when you move off the block, you get that gradual decline. And the way we do that is if our bottom hitbox is colliding with a block, we also want to, if the y velocity is greater than 0, it means if the block was moving down, then self.vy equals 0. And what this does is when the pumpkin is standing on a block, or if it's falling into a block, when it gets pushed up above the block, we're going to say, hey, if you were moving down, you are no longer moving down. Which makes sense. Whoops. Attempt to compare number with nil. Block.y. Self.velocity. There we go. So if I go back up here and I wait a little bit and then I move out the block, I no longer just shoot straight down. You can see it's that gradual thing. Let's do the same thing for here. If we're moving up here we go. If we're moving up into a block and we collide with a block and are moved out of it, if we're moving up, set our y velocity to 0, meaning we're no longer moving up. Same thing for the right hitbox, except with the x velocity. Oops. If we're moving to the right, we're no longer moving to the right. If we're moving to the left, we're no longer moving to the left. And that's better. And it all still works. So I think I'm going to call it for there. That was a good hour and a half of making a pumpkin. We now have like the structure of a platformer. There's still a lot to do, like we want to have a tile-based grid so it's really easy for us to make platforming levels. We'll do that next time. Feel free to post any questions in the comments or message me on Twitter. Always happy to answer anything you got, but thanks so much for watching.